Okay, a kind of important, and you know stuff about moment of inertia, we start down here, here's where the board is. Kind of important thing that we need to be able to do is fit an exponential or a power function to a couple of data points. You'll see how this works out in some later assignments, or why it's important. So if we have data points 4, 2, and 7, 5, well, I drew what I thought was an exponential an approximate exponential function that would go through these points. I estimated the y-intercept to be 0.4 just so I'd have something to check myself on, but that's not relevant to the solution. The function, exponential function of this, but through these points, will have the form y equals a times b to the x. Okay? If y equals a times b to the x, then since y equals 2 when x equals 4, we have 2 equals a times b to the 4th. Plugging in the y value here, plugging in the x value for x. Doing the same thing with the point 7, 5. X is 7, that goes here where x is. Y is 5, that goes where y is, and there it is. Okay, that gives us two simultaneous equations and the two unknowns, a and b. Now the more standard technique for solving these two equations, and I've just repeated the equations up here, is to solve one equation, say for a, and then plug that solution in for a, giving you an equation in b, solving that equation. What I'm doing here gives you completely the equivalent thing, but it's a handy technique. If I divide, because really what I want to do is I want to eliminate one of the variables. That's what I just said is one way to do it. Another way in this case is simply divide one equation by the other, because then you'll be dividing a by a, among other things, and it goes away. You've eliminated it. So I do that here. I divide the second equation by the first. I divide the left-hand side of the equation, the 5 divided by 2, and then the right-hand side of the second equation by the right-hand side of the first, giving me ab to the 7th divided by ab to the 4th. So here's your first equation, here's your second equation. This is equal to this, and this is equal to this, so this is equal to this. The a's divide out, and I end up with b cubed equals 5 halves. Then you're probably going to want to do this cube root of both sides, and that's fine, but I prefer it to do exponents. B to the 3rd raised to the 1/3 equals 5 halves to the 1/3. Use of exponents is a little less complicated than use of radicals, but if you're good with radicals, I've got no problem with that. They get fairly complicated though. Okay, so the solution to this, I take the 1/3 power of both sides, giving me b to the 3 times 1/3, which is just b to the 1, or just b. So I'll erase that 1 off of there, leave it smudged. And that's equal to 5 halves to the 1/3. Now I estimated 5 halves to the 1/3. It's less than 1.4 because 1.4 cubed is about 2.8, and this is 2.5. And it's greater than 1.3 and closer to 1.4 than 1.3, so I went with 1.37. That should be good within 100th at the end here. So I get b equals about 1.37. I plug that back in to the first equation. I could have plugged it into the second, it wouldn't matter. Plug it into the first equation, which gives me this. 2 equals a times b to the 4th, b being 1.37, that's 1.37 to the 4th. And then a is going to equal 2 divided by 1.37 to the 4th. And I vacillated between 0.7 and 0.6 here, vacillating a bit on the value of 1.37 to the 4th. I went with 0.6. The 1.37 to the 4th should be It's 2.5. Yeah, okay, about 3.34. Okay, that still works. Just checking myself. Okay, should be about 0.6. And use your calculator to get all this more accurately. So our exponential function y equals ab to the x should be y equals 0.6 times 1.37 to the x. Using this value of a, this value of b. That gives me a y-intercept when x equals 0, obviously, of 0.6 compared to my 0.4. Okay, so obviously my calculator's wrong. No, it's hard to draw this with a whole lot of accuracy. So, you know, the scale on my graph and whatever, and the shape of my curve could easily have me off by 0.2 there. So this is a reasonable estimate. This is more accurate. And if you use your calculator, you can find it much more accurately. Okay, so there's how we can take two data points and get the exponential function that fits those points.